Hey guys, this is Fraser from Thanks My Tutoring. Today we're going to be looking at this 6 mark. It's on the SL paper. It's a trick question. It's on the SL paper, but it could easily be on the HL paper. So it's for both HL and SL students. It's a good practice. And we're basically just going to be solving a trig equation, which is ubiquitous for in IB exams. You're almost guaranteed to have at least one in your paper 1. That's always the case. So let's get into it. So the first part is a simple 1 mark. So we have to show that these two equations are the same, basically using some trig identities. And whenever we have sine or cosine squared, which we do indeed have, I'm immediately thinking of the identity that cos squared x plus sine squared x is equal to 1 for all x. So immediately writing it like this, we can substitute, and you can see that we go from a cos squared over here to a sine squared. So that's probably good. And the reason we do this is because we want the entire equation to be in terms of sine, while in the beginning it's in terms of cosine and sine. Okay, so let's go substitute that. So that means that I can rewrite that as, that means that cos squared x equals, or 1 minus sine squared x. So we just plug that in. So 2 times this, 2 times 1 minus sine squared x, that's our cos squared, plus 5 sine x equals 4. So actually what I'm going to do is I'm going to multiply everything by minus 1 just to simplify this. So this becomes minus 1 plus, this becomes minus, and this becomes minus. So that's going to be 2 sine squared x minus 5 sine x, and then what we're going to have is minus 2 here, right, because 2 times minus 1, 2 times minus 1, but then we're going to be adding 4 on both sides, because we got to get rid of this to get 0. So it's going to be minus 2 plus 4, so it's going to be plus 2 equals 0, and we have the same equation. So this and this. It's a little squished, not quite enough space, but I think the idea is there. And usually they'll give you, like they'll tell you how you need to simplify the equation in order to make it solvable, in order to make it easy to solve at least. But you will have to know the trig sort of manipulations for that, right? How to manipulate these equations. So that's the first part. That's only 1 mark. It's relatively easy, and usually whenever you see a cosine or a sine squared, that's going to be the case. So the next part is the hard one. It says hence solve the equation. So it's the same equation as before, and as I just said, we can't solve this just with cosine and sine. We need one trig function in order to solve it. So what do we do? Well, there's a hint, because it says hence, and just hence, not hence or otherwise. We have to use this first part. And what did we show? We showed that this is equal to this. So that means if we want to solve this equation, that's the same as solving this equation. 2 sine squared x minus 5 sine x plus 2 equals 0. So what do we do? Well, we're going to try and factorize. Usually they give you these in terms of nice factorizations, and actually this is going to be a nice one. So we have to think of 2 numbers that multiply to get 2, and then so I'm going to go minus 2 and minus 1, and the reason I'm going to do that is because when I expand this, I'm going to get 2 sine x times minus 2 is minus 4 sine x, and minus 1 times sine x is minus 1 sine x, so minus 4 minus 1 sine x is going to be the minus 5 that we need. Okay, so what do we do then? But now we have to solve, these are basically, this being equal to 0. So now we have to solve each of the individual brackets being equal to 0. So either 2 sine x minus 1 equals 0, or sine x minus 2 equals 0, right? Because if either factor is 0, then the entire equation is 0. So this one becomes sine x equals 1/2, and this becomes sine x equals 2. So immediately, this one here is alarm bells, right? Because we know that sine x oscillates, that's a terrible drawing, oscillates between 1 and minus 1. So there is no real value for which sine x equals 2. So that means that this one has no solution. No solve. No solution. I guess you could put solution. So now we can leave. Now we look at the left-hand side. sin x equals 1/2. So luckily this is a nice value, and obviously they're going to give this to you nice values because it's a paper 1 question, which means you don't get a calculator. So what do? We go x is going to equal 2, and sin x of 1/2 should be pi on 6 should be 1/2. So obviously you also need to know your trig values in order to be able to do these questions, because otherwise you won't be able to find the x ones. But because it's always because they always give you nice ones, it shouldn't be too bad. But yeah, sometimes they're going to be a little bit annoying, but you'll just have to like figure it out using the basic ones. So sine of pi on 6, pi on 3, pi on 4, pi on 2, pi. You'll have to just know a nice couple of values, and then you can use the symmetry. So pi on 6, but there's definitely more than one solution, right? Because what we're looking at is the equation sin x equals 1/2, which looks like this. And we're interested in these intersection points here, here, and here. So we found the first one, pi on 6, and we know that this pi on 6, like this value here is pi on 6, right? So if we try and draw that down, so this value, like this, is pi on 6. This here is pi, and because sine is symmetric, so if you this sort of upper part it's meant to be symmetric if the drawing was nice, because it's symmetric. We know that if we move backwards from the end point by pi on 6, we're also going to get a solution, right? So there's a symmetry here, because if you flip like this top part, if you sort of imagine flipping it like that, rotating it, you're going to get the same graph. So what we then do is we do pi minus, because this point here is pi, right? That point there is pi, so pi minus pi on 6 is going to be 5 pi on 6. So that's our other solution, and because the range that they've given is 0 to 2 pi, there are no other solutions, right? There's only going to be 2 here and here. So that's all of the solutions. So that means that the solution set is x equals pi on 6, 5 pi on 6. So that's it. That's the question done. Nice to box your answer. So it's actually not too bad, this one, but they can be quite tricky, but the method stays the same. We usually will do some sort of trig identity at the beginning, try and prove some result, which we're then going to use. So prove some result using some basic trig identities, and then try and solve an equation. And this equation will almost always end up in some sort of quadratic like this, which you then factorize, and then you solve the individual. Because once we're in this, right, we know how to solve this, because we just manipulate it. So sin x equals something, take the arc sine, and then manipulate that. And of course, if this here was like if this bracket had some actual solutions for it being equal to 0, for example, if it was sin x minus 1 instead of sin x minus 2, then we would get some more solutions, right? Because then we would also have over here the x could equal whatever, pi on 2, 3 pi on 2, right? So those are some solutions. But in this case, there were only 2. So hopefully that was clear. Now, as always, if you feel like you need more tutoring with this kind of stuff, a bit more help, feel free to head over to Think Smart Tutoring. The link is in the description. It's very flexible. We have online tutoring, or if you're based around Amsterdam, then we can do real life as well. But yeah, see what fits you, see which schedule fits you. It's very flexible. As always, again, the tutors always have a recommendation for the hours and how the lesson should be structured, but ultimately it's up to you guys as students to decide. So yeah, feel free to head over to there. I'll be making more of these videos, and see you guys soon.